Write a quadratic equation that has the given roots. How do we do this? Now, for example, if we have 1 and negative 3 as the roots of a quadratic equation, there are two methods. The first method is what? The given is 1 and negative 3. For the first method, we're going to set this as x equals 1 and x equals negative 3. Now, transposing this to the other side, this will give us x minus 1 equals 0 and x plus 3 equals 0. Now, for us to find the quadratic equation, of course, we need to multiply x minus 1 and x plus 3. Now, this is, you can make use of FOIL method or the distributive method in using this. So, by the distributive method, we have x squared plus 3x minus 3 equals 0. That's using the distributive method, and then x squared 3 minus 1 is positive 2x minus 3 equals 0. So we have the quadratic equation. Another method is to find the sum and product of the roots. So to find the sum, 1 minus 3 is negative 2. The product of this is 1 times negative 3 is negative 3. Now, from the sum and product formula, we know already that this one is equal to negative b over a, and this one is c over a. Therefore, from this, we can say that b is equal to positive 2, c is equal to negative 3, and a, since they do not have a denominator, a is therefore 1. So, to get the quadratic equation, we simply substitute to the standard form a, x squared plus bx plus c equals 0. Our a is 1, so that's x squared. Our b is 2, so that's positive 2x. And then c is negative 3 equals 0. So that is the quadratic equation. To find the quadratic equation given that the roots are 11 and 1, let's start with method 1. For method 1, we simply put an x and take the opposite side of 11, so that's negative 11. Do the same thing for 1, so x minus 1. And then you can apply here the FOIL method or the distributive method. So we will have the FOIL. So first terms are x and x, which is x squared. Outer terms are x and negative 1, which will give us negative x. Inner terms are negative 11 and x, so that's negative 11x. And last terms, we have 11 and negative 1, so that's positive 11. Combining this will give us negative 12x. So the quadratic equation that we are looking for will be x squared minus 12x plus 11 equals 0. Method 2, we simply find the sum, which is 11 plus 1 equals 12, and the product, which is 11 times 1 equals 11. Now, this sum is equal to the negative of b divided by a, while this product is equal to c over a. Therefore, our a value, since we do not have denominator, is equal to 1. Our b is the negative of 12, so we have negative 12, while c is 11. Substituting this to the standard form, we have x squared minus 12x plus 11 equals 0. If we have 3, 8, and negative 1 as the roots of a quadratic equation, let's find the quadratic equation using method 1. So this will be, this one here will become 8x minus 3. And this one will be x plus 1. This happens by simply using the denominator as your coefficient for x and then take the opposite sign for the numerator. So here, just the same, x and then take the opposite sign of negative 1. Then here we can use the distributive property, so we will have 8x squared, 8x, negative 3 times x is negative 3x, negative 3 times 1 is negative 3 equals 0. Combining this, we will have 8x squared, 8 minus 3 is 5, so positive 5x minus 3 equals 0. This is the quadratic equation that we're looking for. Now, Amas. For method 2, we simply find the sum and the product of the roots. So 3 over 8 added by negative 1 will be, let's cross multiply, so that's 3. 8 times negative 1 minus 8 over 8. 3 minus 8 is negative 5 over 8. Now let's get the product. The product is 3 over 8 times negative 1. So just multiply 3 by negative 1, that's negative 3 over 8. Now from this, we can find the value of A as the 1 in the denominator, and we have 8. So A is 8. Our B value is the opposite sign of our sum, so that's positive 5. And our C is negative 3. So therefore, the quadratic equation that we are looking for is 8x squared plus 5x minus 3 equals 0.